Hey y'all, welcome to a short video on completing the square. We're just going to do a couple of examples so that you can get the procedure in mind and kind of practice it before your test. So what is the process of completing the square? Why are we completing the square? Well, let's say that I gave you a problem that looked like this, right? And I told you to find the solutions. I told you to find the roots. In other words, I want you to find x. And you see a trinomial and you're like, great, I can factor this. This is Texas where I remember Mama. So there's a beautiful rainbow over Texas. I multiply a and c and I get -8. Nope, I get -16. -8 times 2, and then under the beautiful rainbow there's a nice pot of gold, and that's -20, right? So again, the reason why I say where I remember Mama is because I know I have to multiply to -16, but then actually add to -20. So let's look at the factors of 16. Well, that's 1 and 16, 2 and 8, 4 and 4. Okay. Are any of these ever going to give you 20? No. So I actually can't factor this in the usual way. And if you don't want to resort to the quadratic formula, this is one of the uses of the completing the square method. So let's try to solve this via completing the square. So y'all know that the first thing that I'm going to do is actually take this problem and I'm going to move the constant to the other side. Now, before you even start, I want you to think about the leading coefficient as a lock. If it is not a 1, I can't use it as a lockpick to unlock this lock. I can't go ahead and start completing the square. So let's go ahead and unlock this problem so that I can start completing the square. And I'm going to do that by turning that leading coefficient into a 1. So I'm going to divide everything by 2. And I get x squared minus 10x is equal to 4. Alright, notice that this whole time I've been leaving a little bit of wiggle room. So why am I doing that? Well, let's look at the actual title of this process. Completing the square. What's going to happen is you're going to complete the left-hand side of this polynomial, of this equation. You're going to complete this polynomial so that it'll factor into a perfect square. You're going to force this polynomial to be factored into a perfect square, therefore completing the square. Okay, so let's actually start the process for this. This always kicks off by taking b, the coefficient in front of x, and dividing it by 2. So I'm going to get -10 divided by 2, -5. This is what I like to call my magic number, which is going to come back to us in a really big way. Okay, next procedure is to take this number, this magic number, and square it. So what is -5 times -5? Well, that's 25. Now, this is like a little magic trick when you ask people to like double your age and subtract 7, and is this the number you started with? So the next thing you're going to do is you're going to add that number you just squared to both sides. Now you have completed this polynomial so that it's going to factor perfect into a perfect square. And I'm going to prove that to you. Let's factor this guy. I know that I'm going to have to multiply to 25 and add to -10. So that's -5, -5. Okay, well that factors so that I have 2 factors of x minus 5. Or if I want to be more efficient, x minus 5 squared. Hey, I just factored to the left-hand side into a perfect square. So again, you completed the polynomial in order to factor it to a perfect square. Now the right side was just positive 29, right? Nothing really fun happened there. Now, I told you that this number would come back in a big way because if you notice, every single time that you factor the left-hand side after you have completed it with this little procedure is going to factor to x plus your magic number squared each and every single time. So that's kind of nice about it. You can skip all the factoring and just put your magic number in there. Well, what was the whole reason for doing that? Well, now I can square root both sides and actually find this variable x. So I'm going to square root both sides, and I'm going to end up with on the right side plus or minus square root of 29. Why plus or minus each and every single time plus or minus? Because, well, if you square root, let's say that you're square rooting 4, right? Hey, your answer could be 2, but you don't know if the number that multiplied by itself was actually negative. 2 times 2 is 4, but so is negative 2 times negative 2. So you never know if your answer was positive or negative to begin with. So you're always going to include a plus or minus. Now, I am still, after all of this, not solve for x. So the very last thing that I'm going to do is I'm going to add this 5 on both sides, and I get x is equal to 5 plus or minus the square root of 29. This is my final answer. So, seems like a lot of work. However, realize that this number you could not have obtained using our regular factoring methods, right? Now, I love this kind of answer because the more complicated it is, the more I can just leave it like that. But I will expect you to, if you have an example that's nicer, like let's say you have something like this, to actually solve for x all the way through. What do I mean by that? Well, let's actually complete the square for this guy really quickly. As you can see, I left my little bit of wiggle room. Hey, I have a nice lock pick, so I can actually start this problem. And I'm going to kick it off, again, always by taking b and dividing by 2. So I'm going to take that, divided by 2, I get negative 2. This is my magic number that's going to factor my left-hand side into a perfect square. But before I do that, I'm going to take that magic number, I'm going to square it, I get plus 4, right? That's what I put in my little blanks and my little bit of wiggle room. And now this left-hand side, I could do all of the factoring that I did before, or I could just say that it's always going to factor to x plus my magic number squared and save myself the trouble. The right side's going to be 16, and finally I'm ready to isolate x. So I'm going to square root. So I have x minus 2. Then I'm going to remember that I have to put a plus or minus every time I have square rooted a number. And you're probably screaming at me right now, telling me that this is just 4. Well, you'd be right. So let's isolate that x, and you're going to get 2 plus or minus 4. Now here's what I mean. Right here is usually where you would stop if you had a number that you had not square rooted perfectly. But since the number is nicer, I will expect you to split this up into 2 plus 4 and 2 minus 4. So you have x is equal to 6 or x is equal to negative 2. So the nicer the number, the more work you actually have to do. Those are 2 really good examples, I think, of completing the square. So good luck, y'all.